recording. Cool. Awesome. So, welcome to remote learning. I have not planned many interactive things to keep you engaged, but I'll come up with some fun questions to ask you to make sure you're still awake there. Maybe I'll throw up some polls or something. So today we're going to talk a little bit about topography. Your chapter went over contours and contour intervals. It went over US topo, 2D, 2.5D, and 3D data, digital elevation models, some of the applications of digital elevation models, and also LiDAR. So let's start off with a poll. Add a question. Oh, this is not as easy. Never mind. How about you just tell me in the chat? How many of you have used a map that has contours? Okay. Cool. I think a lot of us have seen contour maps before this chapter. So here's one of them. Oops. Adjust that. Okay. Awesome. Haley says she had to analyze one. Yes, I had to too, actually. I had to create a watershed map connecting all the mountaintops. Good. Cool. So for contour maps, you could potentially have an infinite number of contour lines on your map. But that is a bad idea. You, of course, don't want to overcrowd it so that it's useless. So a contour map like the one on the slide has a good amount of them. You can also see all the different things. You can see the contour lines. You can see a lake and a marsh. There's a trail with dotted lines. You can see an unpaved road, streams, forested areas are green. It ends up being pretty intuitive. And you can tell the tops of mountains because they're usually a circle or a blob shape. And then you can see how the slope goes down to a lower land, lower areas. You can also tell where creeks and valleys are by the way the arrows are pointing. I call them arrows. They're not. It's the contour lines when they come to a point. That's a valley. All right. Let's look at a USGS, US topo. Hold on. I'm going to let my dog out. I've got a dog and 3 kids, so often I will just have to deal with that. Hi. Okay, sorry about that. Okay, so USGS topo maps, they are no longer being produced and they haven't been produced for several years. So it's a little antiquated, but they had topo maps, or they still have them archived, for the entire country. And this is one I pulled of Fitchburg. You can see the mountainous terrain. You can see, I think that might be, if it's not a road, it's a railroad. I know the railroad's here because I can see the crosshatches. You can see all these different mountain peaks. So topographic mapping has been around for over 125 years, but the old topo quads have been replaced by a different series of maps. And there's a great online tool linked in your book, chapter 13, hands-on application 1. And it lets you look at the quads over time for the same area. You can also see old topo maps on Earth Explorer, which is earthexplorer.usgs.gov. You can also see them on LibreMap, LIBREMAP.org, and that will let you see some of these old topo maps. So above and beyond having them, map production has changed as well. So it used to take a really long time to produce a map. You can imagine doing this by hand would be quite tedious. But now they can produce more than 100 topographic quad maps per day. And they do the whole country on a 3-year cycle. So they keep them up to date, and they are a key product of the Geologic Service. So they now have more than 175,000 of these in digital format, and they have old historic ones saved. You can also, in the book, Hands-on Application 13.2, it shows a link to download a bunch of them in GeoPDF format. And but we're not going to go over that because I'm going to keep the lecture pretty short today just because online learning can be a bit burned out. And I also want to go over how to connect to the lab computers. Ooh, that's a good question. In chat, how many of you actually are in lab right now? It's okay if you're not in the lab. Okay, cool. So at the end of my lecture, we'll go over how to access the lab computers from home. Great. All right, for the difference between 2D, 2.5D, and 3D, 2D has no Z values, no third dimension, no elevation, no depth. 2.5D only has Z values for one coordinate, for each coordinate, but 3D can have them for multiple for the same coordinate. So you can have one space and time, wow, not talking about time yet, one point in space and have the elevation all around it. So you can see a really good 3D image. So most digital terrain models just have one elevation model measured for the terrain height at each location. So most of them are 2.5D models. However, I think your book mentions that they call them 3D anyways in the book. Actually, most people call them 3D anyways. It's just the easy way to describe them. So you could take these topo maps. They don't even do them this way anymore, but you can make a digital elevation model out of them. Now they use LiDAR. So the digital elevation model is a specialized database that represents the relief of the surface between points of known elevation. So you interpolate the elevation data from surveys or data captures, and then you create a grid to show the DEM. And from this digital elevation model, which is this top one over here, you can create a slope, which I think is probably this one. That shows the slope. So slope is the steepness or the degree of incline of a surface. It can't be computed from the LiDAR points directly, but it can be calculated from the DEM. There's a mathematical formula behind it. We're not going to go over it because the computer calculates it all for you. But basically, it's the change in elevation between one pixel and the next, 1 point in time, 1 point in space, and the neighboring point in space. And then it tells you how steep a hill would be. So this, okay, we did slope. Aspect is this one. It's the orientation of that slope. We talked about this a little bit before. It measures it from 0 to 360. 0 is north facing, 90 is east facing, 120 is south facing, and 270 is west facing. So you can actually see from this that probably the red ones are south facing. I'm going to guess. Usually there would be a legend, but I pulled this image from the internet, so I couldn't tell you exactly which one is which. It's like one of those magic eyes where it keeps flipping on me. So the final thing you can make from DEMs that we're going to talk about, lots of other things you could make from a DEM. The final thing we're going to talk about is a hill shade, which is this one. So if you want to visualize the terrain as like a shaded relief, as a really cool background, you can illuminate it with this hypothetical light. So the illumination value is oriented to the sunshine source, your hypothetical light, which the computer uses slope and aspect to determine how to make the hill shade. So it makes a really, really cool background for stuff. All right, so I am going to try to play a video. You have to let me know if the audio works. But first I'm going to tell you how to talk about LiDAR. So we talked a little bit about it before, but I'm going to talk a little bit more. LiDAR is like firing a laser beam at a target, and then the light bounces back, and whatever device you're using will capture it. There's both LiDAR from planes, which is kind of the most common right now, and there's terrestrial LiDAR, which actually is a backpack system. It's pretty cool. So it's a very effective means of collecting terrain data, and it results in really great high resolution digital elevation models. There is a very good LiDAR tutorial video online, and it's linked in your book at the end of the chapter. LiDAR can also collect elevation heights, not just of the ground, but of trees and buildings. So you can create 3D profiles. And the video we watch actually will show you some of that. I don't know if it goes into it, but there's a really cool LiDAR-based 3D model of the Golden Gate Bridge in San Francisco. That's really cool. There's also LiDAR images of Ground Zero available online. It takes a look at the destruction, and it also showcases LiDAR's ability to capture the dimensions of a site and nearby buildings. And they use that to aid in recovery. Okay, so let's try this video. This video is about the Amazon jungle. This guy is Greg Asner. I actually got to meet him last spring. It was really cool because he's kind of one of my idols. Okay, is the audio working? Okay, so I'm hearing that you cannot hear it now. All right, so what I'm going to do is I am going to send you the link and let you watch this video. It is 13 minutes long, so go ahead and watch it, and I'll check back in with you at 8:30. I'll leave my screen up and ready. That'll give me a chance to finish making coffee too. Okay, so you should just be about at the end of that TED Talk. When you come back, you can answer in the chat. What do you think of it? What were the most interesting parts? Okay, yes, it can be so detailed that it maps out the treetops. It can map out individual trees, estimate the carbon, tell you if the tree is healthy, which limbs are unhealthy or dying. And you can imagine all of the uses that would have for conservation, for urban tree planning, for just light departments who might have to come in and trim. Anybody else? What did you think of Greg's talk? If I'm muted and it looks like I'm talking, it's because I'm yelling at my kids or my dog. Yep, the digital imaging is very complex, but it's interesting. There's no more Frosty Paws. I'm going to turn off my virtual background so you can see the insanity that happens behind me sometimes. Definitely will keep you entertained. Okay. So Greg's talk, super interesting. Thank you. He is always looking for undergrads in his lab. Well, with the pandemic, it's a little different, but he lives in Sacramento, California. He does a lot of work on the coral reefs outside of Hawaii. Haley, what did you think of Greg's talk?
I think it was all really interesting. Like the way that he was able to have all of the technology and like be able to like map it like 3D.
Yeah, it's super, super cool. So I was just telling everybody that Greg is an awesome professor and researcher, and he's always looking for undergrad help. Let's see. His website is asnerlab.org. If any of you ever wanted to apply for like summer research things. I do not know if he's hiring right now because of the pandemic, but he often does. He's part of the grad school that I was originally planning to go to before this pandemic happened down at Arizona State. But fortunate for you guys, I stayed up here. Cool. So let's go over how to connect to the lab computers from home. So I know a couple of you already are able to. If you are on Blackboard, let me share this screen again. If you are on Blackboard, your screen should look close to this. I have edit mode on, so it's going to look a little different. Right. It should look like this. And it'll say how to connect to the lab computers from home. Right? So it tells you to go to desktop.fitchburgstate.edu and install the VMware Horizon client. You find the one that works for your program. We did find out that there's also a client for Chrome. And then run it. And it's going to have you log in with your Falcon key credentials. And then you can access, what are you eating? You can access it. So I'm going to go ahead and walk you through that here. And I will also put this in the chat for those of you who are not able to access the PDF for whatever reason right now. You click install, it'll bring you to this other site that has the different software. And I have Windows, so I'm going to use this one. You hit download, and it's going to download it. I already have it, but I'll just run through the process anyways. It should be a pretty quick download, except for, oh, Chris isn't on. If you have trouble downloading it, the lab computers are always open, so you can go to the computer lab. A lot of the software for the rest of the class is, actually, we'll walk through the labs and I'll tell you which software you'll use if you don't want to connect to the lab computers. So if you do want to, once that's downloaded, you click on it to run it. It'll pop up and say, do you want to make changes? You hit yes. And it's installing somewhere in the background and I can't see it because I'm sharing just my thing. Let me share my whole screen. Share. Yes, I can't minimize Zoom. I understand that, but like I need to see this. Okay. So yours will say install or something. I already have it, so it's giving me these options. It'll run through it and it'll have you, yeah, where? It'll be this icon when you're done once it's installed. And you click on that. There it goes. And I can connect to desktop.fitchburgstate.edu and I can sign in with my username and password. And I can connect to one of these. This is like the front of the classroom podium. This is the library lab, and this is the geo lab, and that has all of the software that we need.
And Artie's trying, oh my gosh, he's bleeding.
He's always bleeding, my dog. And then you have to sign in again, just like you were at the lab computer. And this is going to be in this recording, so you will always have access to this. Quick tutorial walkthrough. So it's going to pop up in a second, and it's going to be just like you're sitting in front of the lab computer with all of those options. Eventually, when it loads. Okay, well, while that's still preparing, let's go over the software if you don't connect to desktop. Oh, here it is. Okay, it loaded. So you can see it looks just like a desktop in the labs.
Do you mind if I throw this at him?
You cannot throw that at him.
Not at him, but near him.
Just go back to your room.
I need to get my school computer.
Well, just go do it. He's not going to bother you. All right. And I'm going to leave this running in the background, actually, just in case I need it. So back to Blackboard. Let's see. Stuff you will need for the rest of the semester. It is week 12. Week 12, we did this. Tomorrow is GIS day. Come join me for coffee. You have to register and then they'll email you the Zoom link. We're doing like a mapathon and different lectures and stuff. It'll be lots of fun. Totally optional. Maybe I'll give you bonus points if you sign up and come. Let's do that. Yeah. 10 extra credit points if you come to GIS day and email me the most impactful thing you did at it. Most of you are already getting A's in this class, so like don't feel obligated. But if you love GIS, it's a great chance to connect with a whole bunch of GIS users all over the state. I know there's 40 people already signed up. There are people that might offer you jobs. There are lots of learning opportunities. So it should be a good time. All right, so Thursday, we're gonna do chapter 13 lab, and this one uses, that's not what I wanted. This one uses Google Earth. So if you don't want to log into the lab computers or you can't, you can download Google Earth on your own computer.
Is he allowed to have his container because he really likes it?
No, he should not. Give him something else to chew. For homework, you're going to do the reading and the quiz, as always. Next week is a holiday week, so we will meet virtually on Tuesday. We will not meet on Thursday. Saturday is my birthday, so I expect emails from all of you wishing me a happy birthday. And then the week after, we're back at classes. So, you will still be responsible for doing a lab next week. We're going to try to do it together on Tuesday. And this one uses Google Earth Pro again and SketchUp. So SketchUp is also free. We're going to use the free SketchUp. Yep. So once again, you can download this if you don't want to access the lab computers. Totally up to you which way you want to go. And then that week's homework. And then the week after that, we're going to talk about the future of GIS. And we're going to do a chapter 15 lab. And that one, we're going to use ArcGIS Online, which is browser-based. So you don't need to download any software for it. You will need to download the data set. And then that brings us to the final. You have the option for the final to take an exam, which is 163 questions, or do a final project, which is making a map tour. This is a walkthrough of how to do it step by step. Here's some for inspiration. You choose one of them. It's going to be 18% of your grade. For the final exam, you have an unlimited number of attempts. You have unlimited time. You can stop, go do something, come back to it. It's open notes. So, and I also put it, you get to see the answers that you got wrong after your attempt. So you can like make a note to yourself that these are the things you need to brush up on, and then go back in and do it again. So you can do it as many times as you want. It pulls from a pool of 400 to 500 questions. So let's assume that you did it 10 times. You should end up seeing every single question and knowing the right answer. So I have given you every opportunity to get the full 18 points towards your final grade. And it goes over everything we've covered in the semester. But it's open now, so you can start working on it now if you want. You have like a month to work on it. It's due, I'm pretty sure the 16th, the 15th. So you have about a month to work on it. Or the final project, which I will be grading very leniently. You make a map tour. Here's an example of a map tour. Let's see. We've actually seen map tours before. We looked at a vintage one. I'm gonna make it random and I'm gonna hope this works. Okay.
Mom, what do you call a snail that looks
Abby, sweetie,
like
that's funny. I'm teaching right now, so I need quiet, please. Thank you. Okay. Well, we'll have to go on a hike. So this is not the best example of a map tour. Let's do this way. All right. So here we go. This is a SEE art tour. So instead of doing a final exam, you could come up with something like this. It could be like your favorite spots to make out in your hometown. I really don't care. Like just zoom into the different areas. You can add images. This one doesn't have any, but it tells you a little bit of history about everything. Here, this is a good one. This one is from a fire. So as you see the pictures, The map might swim around. Nope, it just makes the icons bigger. And this is all in the tutorial, how to do all of this. It ends up being a really cool website you could put in your portfolio one day. All right, so that's your option, final exam or map tour project.
No!
Abby, give him something to play with. Okay, that was a lot to take in. Today we went over the rest of the semester, how to connect to computers, topology, Asner's lab, and LiDAR. What are your questions? You can unmute and ask, or you can type them in the chat.